Hello and welcome. In this video tutorial, we will take a look at the homework solutions to Unit 8, Lesson 2, the area of a circle. Remember to pause and rewind the video as necessary. Let's begin. Number 1. If a circle has a circumference of 10 pi inches, then which of the following represents the area of the same circle in square inches? Well, let's go over a couple things at the top. 1. We should remember that the area of a circle is found by going pi times the radius squared. Okay, so if we have a circle, the area is all that in the middle, right? The circumference, on the other hand, is the entire distance around the circle. The circumference can be found by going 2 times pi times the radius. Now, since 2 times the radius is the diameter, we could also say the circumference is pi times the diameter. So you can use either one. It depends on what you're given in the problem. Now in this problem, to calculate the area equals pi times the radius squared, we need the radius, so we should use the circumference equation that has the radius in it. So circumference equals 2 pi times the radius. Solve for the radius by dividing the equation both sides by 2 pi. Cancels, cancels. The radius would be the circumference of 10 pi over 2 pi. You can see the pi's cancel, leaving you with a radius of 5 inches. Okay, throwing this into the area calculation, area equals pi times 5 inches squared. Well, 5 squared would be 25 pi square inches, which is option 3. Now in number 2, it says the design shown below, 4 semicircles are attached to a square whose area is 6 square centimeters. Now a square, the area of a square is each side squared. So if I take the square root of both sides, I'll get the length of the side. The side is the square root of the area, or the square root of 36. Each side is 6 centimeters. Which means that would be the diameter of a circle. Therefore, the radius would be 3 centimeters. So the radius of each semicircle is 3 centimeters. Now, if you were to add this up, those 4 semicircles, this semicircle plus this semicircle is 1 circle, and this semicircle plus this semicircle is 1 circle. So 4 semicircles actually equals 2 full circles. And so that's exactly what we're going to do, is we're going to calculate the area of 2 full circles. So the area of 1 circle would be pi r squared. The area of 2 circles would just be 2 times pi r squared. That's exactly what we'll do. So 2 times pi times the radius, which is 3 inches squared, would be 18 pi. And you can see your answers are not involving pi, so you're going to have to multiply 18 times pi, and that's approximately 57 square centimeters. Number 3, which of the following formulas gives the area of the circle in terms of the circle's radius and its circumference? Okay, so start off with the area formula and the circumference formula. So circumference equals 2 pi times the radius. Now let's solve it for radius here. To do that, we're going to divide by 2 pi. And radius is the circumference divided by 2 pi. Now what we're going to do is we're going to take the area formula. Area is equal to pi times the radius squared. Well, what we're going to do is we're just going to split. Notice the radius is part of each one of your answers. So what we're actually going to do is we're just going to split this up into pi times the radius times the radius. We'll just split up the radius squared into radius times radius. And we'll do that because we're going to substitute 2 pi, a c over 2 pi, in for one of these two radius. And we get pi times c over 2 pi times that second radius. You can see the factor of pi cancels, and we are left with the area is equal to circumference times radius divided by 2. Or you could say 1/2 circumference times radius, which is option 4. Now in question 4, it says the following diagram, a quarter circle has been constructed using an isosceles right triangle whose legs measure 8 inches. Which of the following represents the area of the shaded region, round to the nearest tenth of a square inch? Well, the area of the shaded region is actually the area of the full quarter of a circle minus the area of the triangle. Okay, so that's what we're gonna have to do is we're gonna find two areas and subtract them. So the shaded area, which I'm gonna call A sub S, is equal to the area of the quarter circle, QC, minus the area of the triangle. So if I take this total area right here, the area of that quarter circle, and I subtract the area of the triangle, I'm going to get the shaded area, what's left over. Okay, so let's find both those things. Well, the area of the triangle is going to be 1/2 base times height, or base times height divided by 2. You can see the base and the height are both 8. That's pretty easy. 1/2 8 times 8 would be 64. Half of 64 would be 32. So 32 square inches would be the area of the triangle. The area of the quarter circle. Now, a quarter circle is 1/4 of a circle. Now, the area of a circle is pi r squared. So the quarter circle is 1/4 of a circle. So you're going to take pi r squared divided by 4. Well, it turns out that this base of the triangle is actually the radius of the circle. If you swept it out, you can see that. This is actually the radius of the circle. So we would go pi times 8 squared over 4. And we get 64 pi over 4, which is 16 pi. And that approximates, we're going to go ahead and take the shaded area. So AS is going to be 16 pi minus 32. And when you subtract those, you approximately get about 18.3 square inches. Which is option number 2. Now in question 5, we have this square whose sides are 12 inches long and has been shaded and then overlaid with 2 quarter circles, each having a radius of 6 inches. What percent is the total shaded area? Okay, now percent, just in case you forgot, percent basically means part over the whole. And then times 100 puts it in percent. So part over whole, that's really the concept of percent, okay? Now what's the part? Well, the part is going to be the shaded, to get the percent of the shaded part, it's going to be the shaded region divided by the whole square times 100. So that's how we're going to find the percent part, okay? Now, how do we find the shaded region? Okay, so the area of the shaded region, A sub S, is going to be the area of the whole square Okay, it's the area of the square, SQ, minus, we're going to subtract from the area of the square 2 quarter circles. Now, a quarter of a circle plus a quarter of a circle, quarter plus a quarter adds up to half a circle, right? So it's the area of half a circle. So let's figure these out. Area of the square is going to be essentially base times height, or side squared, and that would be 12 times 12, or 144 square inches. The area of half the circle, now the area of a full circle is pi times r squared, so the area of half a circle would be, of course, half of that. And if you notice, the radius would be 6 inches because it's half the side of one of those sides of the square. So it's pi times 6 squared divided by the 2, and pi over 6 squared divided by 2 would be 36 pi over 2, which is 18 pi. Okay, so the shaded area is going to be the 144 minus the 18 times pi, and that's about 87.451 square inches. Okay, so that represents all that shaded part right there. Okay, now to find the percent of what's shaded, the percent shaded, all we're simply going to do is take the part that is shaded, 87.451 square inches, and divide it by the total area of the square, 144 square inches, and then times 100 puts it as a percent. Notice the units cancel, and you end up with about 60.7%, which you can just round up to 61%. So this figure is basically 61% shaded. Question 6, we have a semicircle with its diameter is the hypotenuse of a right triangle. Determine the area of the semicircle to the nearest tenth of a square centimeter. Show how you arrived at the answer. Okay, so again, if anytime I see an angle and a side, I need to know I'm going to be using right triangle trig. Okay, now what am I looking for here? This is the angle. This is the adjacent side because it's right next to the angle. And this is, of course, the hypotenuse. So adjacent and a hypotenuse go with cosine. So I'm going to use the cosine ratio. Now, cosine, if you remember the SOHCAHTOA, the cosine ratio is equal to adjacent divided by hypotenuse. So the cosine of 68 degrees is going to be equal to the adjacent side divided by the hypotenuse, okay, which would be cosine of 68 equals the adjacent side, which is 7, over the hypotenuse, which I'll just call h. Now, the easiest way to solve this type of equation where your answer or your solution, the variable you're looking for, is in the denominator, the one way you could do this is, of course, put this over 1, take your cross products, and then isolate it that way. But that takes, an extra step. If you just simply switch this out with the other side, you accomplish the same thing much faster. So h is actually 7 divided by the cosine of 68, which means the height of that, I keep calling it the height, not the height, the hypotenuse. Sorry, didn't mean to confuse you. The hypotenuse would be 7 divided by 0.3746, and you actually get about 18.686 centimeters. Now notice that's the whole diameter of the circle. So which means the radius would be half of that. The radius would be 9.34 centimeters. Just cut this number in half. Okay, so we want to find the area of the semicircle. So now the area of a semicircle would be pi r squared divided by 2, because a semicircle is half a circle. So pi times 9.34 centimeters squared divided by 2. We get approximately 137 square centimeters. Make sure you practice putting that in your calculator so that you arrive at the same solution. Okay. Now in number 7, you start off with a circle equation here that apparently we need to put in proper form, in HK form, vertex form, or standard form rather, and determine the center of the circle. So let's start by spreading this out. This will be x squared plus 2x plus leave some space for b over 2 squared plus y squared minus 4y plus leave some space for b over 2 quantity squared. And that's going to equal 12. Just leave a little more space there. Okay, identify your b terms. There's b term. There's b term. And so for the first set of b terms, the first b term, we're going to go 2 divided by 2 is 1. Square that, we get 1. So we'll subtract 1 over here. My second b term will go -4, take half. That's -2. Square that, we get 4. And I'll subtract 4 over here. So I'm going to add the -4 and -1 while simultaneously grouping my x and y variables. So I get x plus 1 squared plus y minus 2 squared. And then this part right here is -5. So -5 equals 12. So go ahead and add the 5 to both sides and rewrite this, and we get x minus a -1 squared plus y minus 2 squared equals 17. Well, all we wanted to know was the center of this circle for this part of the problem. So the center would be at -1 and 2. So -1 and 2, whoops, would be the center of that circle. Okay, now determine the exact area of this circle. Well, here's what we need. We need, in order to find the area is equal to pi times, oops, not is equal to pi times the radius squared. So we need the radius. So if the radius squared is 17, because remember, we have this term here, r squared, the radius squared. So the radius squared is 17. If I square root both sides, r is the square root of 17. And when I put, and I can actually just replace r squared with 17. So since r squared equals 17, I'll just replace that, make it even easier. So area is equal to pi times 17. And so we're supposed to leave this exactly in terms of pi. The area would be 17 pi. Square doesn't tell us what the units are, so just square units. Okay, and lastly, in number 8, we have a circle O shown with diameter AOB is perpendicular to chord CD. Now, if it's perpendicular to chord CD, notice chord CD has been bisected into this segment CE and this segment DE, equal length, right? So if CD all the way across is 8, well, that means this is going to be 4. Oops, can't see that. This is going to be 4. This is going to be 4. We're told that BE is 2, and we're looking for length AE. So we're looking for the length of this segment right here, the long segment all the way across. Now, we saw this in our last unit, unit 7, which told us that two chords that intersect, we take the product of the chords. So this CE times DE equals AE times BE. AE times BE equals CE times DE. And you're looking for AE. So AE would be equal to CE times DE divided by, we divide out the BE. So CE and DE are both 4, so 4 times 4 over BE, which is 2, and we get 16 over 2, which is 8. Okay, now find the exact area in terms of pi. So the area would be pi times r squared. We need the radius. Okay, what's the radius of the circle? Well, if this entire blue segment is 8, 8 plus 2 means that this whole segment here, the whole diameter, equals 8 plus 2 or 10. So if the diameter is 10, radius is 5. So pi times 5 squared would be 25 pi square units.